All right, so let's continue. The next part might be a little bit confusing. Hopefully when we go through the example, it clear things up. And if it's still confusing, we kind of can recap again next week. All right. Usually, I'll be honest with you. Usually in the previous 2 semesters, this is basically got into like the next lecture. So that might be a chance that we have to break down a little bit further and continue this, like the second half of this in the next lecture. But the overall idea is we want to do a better job at predicting branch, right? Here is a few observations that the previous literature that look into branch prediction. The first observation is when I have the branch outcome, the outcome of one branch usually correlate with the outcome of other branches. We call this the global branch correlation. Basically, it means that if I try to predict the branch outcome of this guy, the outcome of this guy might affect the outcome of this guy. There are not dependency, but correlation between the 2 branches. The second observation is the branch outcome is correlated with the path outcome of the same branch. We call this a local branch correlation. This is kind of like similar to what you saw earlier already, which is the 1-bit and 2-bit predictor, which is the history of the branch. The outcome of that branch affects the current outcome of my branch that I'm trying to predict. All right, we'll start with the first observation on how do we design the branch predictor for this guy. All right, so with the global branch correlation, a simple example can have something like this, right? If some condition 1 happen, A is going to equal to 10. The next line say, if A equals 0, do something. If A equals 0, do something. This basically means that if condition 1 is true, the second if is not going to be true. If condition 1 is not true, then the second if might be true. All right. And that's kind of the correlation across the branches, right? Because the code that you do in one of the if-else block might affect the outcome of future if-else. And how do we detect this? Basically, the idea is, well, we used to take into account of the outcome, the history of each branches individually, right? Whenever you see a branch, you say, hey, what's the history of that branch? I want to be able to detect the global level, on the global level, what has happened in the past, right? The idea is I would add this structure called the global history register. The global history register, what it does is it keeps track of the history of n previous branches. So again, the GHR or the Global History Register would keep track of the last n branches you saw ภาษาไทยนะครับคือไอ้ GHR เนี่ยมันจะเก็บว่าไอ้ branch ที่เราเจอของทั้งโปรแกรมอ่ะไม่รู้จะเป็น branch อันไหนก็ตามของทั้งโปรแกรมเราจะเก็บมา n อันก่อนหน้า n อันก่อนหน้าแล้วดูว่า pattern คืออะไรของ n อันก่อนหน้านะครับ Then we would use another table, the second level, that based on the GHR, the Global History Register, I would have a separate pattern history table. In the second level, I use I mean, the simplest form of the second level would be just 1-bit predictor. I can use a 2-bit predictor. I can use whatever policy, but I would use the GHR to tell which of these table I'm using. Okay. This is in McFarlane Combining Branch Predictor in 1993. All right, and here's the kind of like a overview of the design. So I have the program counter. This is the same thing that you saw earlier. I have a GHR. That's the Global History Register. The Global History Register would index into the direction predictor, I don't use the program counter anymore. I use the GHR. This is the pattern of my n previous branches. For example, let's say n is 4. Let's say n is 4. The GHR might be something like this. Not taken, 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 taken. Basically, it means that the last 4 branch you see is not taken, 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 taken. Or it can be taken, 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 not taken. It basically now means that the last 4 branches you saw from your program is taken, 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 then not taken. All right, so that's the GHR. Now the direction predictor becomes a table with multiple rows. And let's say again, if n is for previous branches, is start from all not taken to taken, 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 taken. So each row here corresponds to what do you do if the GHR is this pattern? What do you do if the GHR is this pattern? What do you do if the GHR is this pattern? All right. So it can be from n, 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 t, n, n, t, n, 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 t, t, n, t, n, 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 t, n, t, n, t, t, n, n, t, 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 all the way to t, 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 t. Each row will contain each pattern. All right. Now, here are some more concrete examples. So let's say this is your program. If I is less than 0, I is less than 5, that's a loop. Then you have 2 if-else condition, right? If I run this program, this is what's going to happen. Let's assume that if this is true, you take the branch, again, for the sake of our assumption, all right? If this is false, it means that I do not take. And for the if-else, this is taken. This is not taken. Again, this is taken. This is not taken. If I were to run this example, basically what's going to happen is I go to the first loop, take the branch. The first if-else, take the branch because I is going to be 0, right? So they're going to take the branch, take the branch. So that's the first loop. The second loop when I is 1. So this is when I is 0. When I is 1, take, take, take again. All right. Then when I is 1, you go into the loop, take the first branch, do not take the second branch. This I is going to equal to 2. Taken, not taken, not taken. I is going to equal to 3. Then you take the loop, don't take the 2 branch. I is going to equal to 4. Then you exit the loop. This is exit the loop. All right, so that's your actual outcome of the branch. All right, with me so far. This is the actual outcome of the branch ก็คือถ้าเรารันโค้ดอันเนี้ยมันจะ take not take take not take not take take not take not take not take นะครับอันนี้คือถ้าเรารันโปรแกรมจริงๆนะครับเดี๋ยวเรามาดูตัวอย่างว่าถ้าเราใช้ไอ้ global predictor เนี่ยมันจะเกิดอะไรขึ้นนะครับ so now let's go through our example using the global predictor you can do example 2 on your own you can try example 2 on your own in this class, so let's do example 1. Let's assume that GHR is 2 bits. So n is going to equal to 2. Just keep track of the last previous 2 branches. And then you use the 2-bit saturation counter for the second level. So the second level, we use the 2-bit predictor that we explained before the break. All right. Okay, here is the branch pattern. Taken, 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 taken. So this is I equals 0, I is equal to 1, I is equal to 2, I is equal to 3. taken, not taken, not taken. This is I equal to 4, and then you don't take this, exit the loop. All right. All right. Now let's, on top, let's say this is a prediction. Now, everything in hardware has to have some initial state. So let's assume initial state also again, because we have to represent taken and not taken. So let's say taken is 0, not taken is 1. So let's assume initial state of GHR is going to be 1, 1, and everything initialized to 1, 1, 1, 1, 1, 1, 1, 1. All right. So that's initially what happened. Now let me change the pen color so that you can see the change. Now the first branch, the way I would work through this is I'll first look at the GHR. What is the GHR right now? I will first look at GHR. It's 1, 1, right? And that, because initially I need to assign to some value. So initially, let's say I assign to 1, 1. What's going to happen is to get my prediction, which is what do I predict? I'll first go to the entry that corresponds to my GHR. In this case, 1, 1. I look at the local counter. Local counter is 1, 1. This is strongly not taken, right? So it's because it's a strongly not taken, I would predict not taken for the first branch. I basically, again, I look at the GHR and then go to the entry that corresponds to the GHR. Then I go look at the local counter and I see what do I do here. All right. Because in reality, you actually take the branch. So this is what you do to update everything. To update the GHR, it was 1, 1 earlier. It was 1, 1 earlier. To update, you saw not take. You saw taken. Taken is 0. So this was the last time you predict, right? 1, 1. You push everything so that the oldest value becomes the 1, and then what you saw the last time was 0 because it's a taken branch. Then you go to GHR 1, 1. Over here, you update because you actually take the branch, but you predict strongly not taken. This is wrong. So you have to update this guy into from 1, 1 strongly not taken. You want to update this to weakly not taken because you saw, hey, if I see the pattern 1, 1 in a GHR, you're actually taking a branch. So I would now become weakly not taken. That's it for the first branch. The next branch, again, I then look at the GHR. It's 1, 0. All right. I look at the GHR and it turned out to be 1, 0. So I look at this entry. This entry has a local counter 1, 1. Again, is strongly not taken. So my prediction again is going to be not taken because of my local counter. Now I have to update. I see taken again. The last two branches I see taken and taken. So I update my GHR to be taken because I see taken in the last two branches. I then have to update my local counter from strongly not taken because I'm wrong. I have to update this to 1, 0. And I'm done. Now I go to the next branch that I have to predict. The next branch that I have to predict has a GHR of 0, 0. So I look at this entry. I look at the local counter is at strongly not taken. So I would predict the branch outcome to be not taken again, right? And then update the local counter to be 1, 0 because I'm predict incorrectly. It's actually taking the branch. The GHR is updated. The last two branch you saw was taken, so it's going to be 0, 0 again. Over here, you look at 0, 0, it's 1, 0, it's now weakly not taken. Strongly, now you are weakly not taken, right? Weakly not taken. Weakly not taken, the prediction is going to be, again, not taken. And because you're wrong, you now update everything. You update GHR. GHR is, again, the last two branches you saw taken, so it's going to be 0, 0 again. Now, this thing is going to change from weakly not taken, 1, 0. Because you're wrong, you're going to become 0, 1. This is weakly taken. Because this is 0, 1, you're going to predict that I will take this branch. I'll take this branch, and you're correct. Because you're correct, you update everything. I mean, regardless of whether you're correct or not, you update everything. From 0, 1, you become strongly taken. 0, 0. So this becomes strongly taken. The pattern stays the same because the last two branch is taken and taken. And you're gonna be in this state for a while. So this is gonna be taken, 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 taken until this particular branch. Again, you're at GHR of 0, 0, right? Local counter is 0, 0, strongly taken. You're gonna predict taken. This would be updated because now in reality, you're not taking this branch. So everything here has to be updated. Now your GHR is gonna become 0 and 1. Your local counter, the last time you see 0, 0, you predict incorrectly. So it becomes 0, 1. It goes back to weakly taken. It's go back to weakly taken. Now, to get the prediction of the next branch, you go to GHR. Oh, I see 0, 1. So I will predict, again, is strongly not taken. So I will predict not taken. In reality, you're taking the branch. So you can say that, OK, last time I see 0, 1, I am taking the branch. This becomes 1, 0. Then I update GHR. The last two branch you saw was not taken, then taken, right? So it's going to be not taken, 1, 0, all right? So yeah, you're back at 1, 0. You look at the entry 1, 0. Once it's strongly not taken, so you're going to predict not taken. Then you update the entry. Because you're correct here, you're going to become strongly not taken again. My bad. That's going to be 1, 1. 1, 1. And now you update the GHR. To the last two branch outcome. So it's going to be taken, then not taken. To taken, then not taken. Then you look at 0, 1. 0, 1 is at weakly not taken. So you are going to predict not taken. And because you predict correctly, from weakly not taken, you update to strongly not taken. 1, 1. GHR, the last outcome of the branch you saw was not taken, followed by not taken. So it's going to be 0 and 0. Oh, my bad. 1 and 1. Oh, sorry. Not taken twice. So it's going to be 1 and 1. 1 and 1. Now you go to 1 and 1. It's strongly not taken. So your prediction is going to be not taken. Then you update because you're wrong again. So the pointer option erase is going to be 0, 1. 0, 1. Then you update the GHR because you see not taken followed by taken. All right, not taken followed by taken. So it's going to be 1, 0. And to make the prediction again, you look at the GHR, you go to 1, 0 in the entry, look at the local counter. It's strongly not taken. So your prediction is going to be not taken. All right. And you stay there because you're strongly not taken. And you saw what you saw earlier is taken, not taken. Taken, not taken. The pattern is 0, 1. So your GHR is going to be updated to 0, 1. Then you look at the GHR of 0, 1, prediction is going to be not taken because 0, 1 is going to be strongly at the moment, strongly not taken. You correct, you stay there, you update the GHR. You saw not taken twice, so your GHR is going to again become 1, 1. You look at the entry 1, 1 is now strongly weakly taken. So you predict taken here. Now with this, you update the GHR from GHR stay the same because the last two branch was not taken twice. But the entry here in the local counter, because you make the wrong prediction, it will go to 1, 0 to be weakly not taken. And that's it, right? So as you can see here, it takes a while to initialize your history. Now, once the history is being initialized to some extent, you get pretty good at predicting your branch. My quick things to try for you guys. Loop again. Do the same process, but with this condition. You will see that it would learn the pattern using a GHR. The local counter for each pattern in the GHR would learn itself. Then it would get better and better at the prediction until it saturates at some pattern. So this would slowly improve the prediction until it saturates and the state of the GHR and the local counter reach some steady state. All right. So worksheet 2 again is for you guys to try. This is a 2-level global predictor. All right, 2-level global predictor. I do recommend, first of all, try this again with the, like, let's say you have to run this loop again, for example, right? Do the whole thing again using this condition. You see that the prediction gets better. It gets better. For example, the next loop. Oops, sorry. Let's say you have to loop the whole thing again, right? The next time you run this, because GHR, right, that you saw earlier, is 1, 1. You make some prediction, and then you start being correct really quickly. So you predict the next time you see this guy, you're going to become taken and taken because the GHR kind of learned the pattern, right? And then keep checking and see if you get better. The second worksheet is for you guys to practice this again, using a different loop and if else from the example I showed you earlier. Now, aside from the global predictor, what else can we do, right? So you can add more. For example, you can add more information, make the GHR bigger. Once the GHR gets bigger, again, it takes more time to train your GHR and the local counter, but it's going to get even better. You can also try to use the branch program counter as another information. So the idea of another predictor called G-share prediction is to XOR the GHR with the program counter to even try to get better and try to put in the local information, like where is the loop that you're trying to understand right now. So the G-share, instead of the GHR directly go to the direction predictor, you XOR with the PC, and otherwise the rest are the same. So that's the global branch correlation. The second observation is about local branch correlation. Local branch correlation is a little bit simpler than the first idea to explain. Local branch correlation is proposed in Micro 1991. This paper has a lot of gain a lot of traction. It's actually kind of like this idea has been used in the CPU in around that day and age. All right. So the idea is, let's associate the outcome of the branch with the history of the same branch, right? So you would use the local history register, which is it looks like a GHR. it looks like a GHR, but it's the pattern for each branch. For each branch individually. So each branch will have its own local history register. And the second level is just basically now it's a table of the saturating counter, that maybe the 2-bit counter, 3-bit counters to predict the outcome of the branch. So the structure is going to look like this. The program counter is now used to index into each individual local history register. The pattern of my local branch would dictate my outcome. Then the rest would work kind of the same, right? So here's an example, same loop, all right, same loop. So I'll use this example 1 to drive the example of how does local history register work. Okay, here. Now you have branch 1, the for loop. Branch 1 is going to be taken, then not taken. You exit the loop. This is branch 2. Branch 2 is going to take, not take. This last if else is branch 3. This is going to become taken, not taken. Okay. So now if you want to work through this, branch 1 pattern is going to be take, not take, not taken. And let's assume for the sake of simplicity, everything initialized like all once. Now, the difference between the GHR and the LHR is that the LHR, you go branch by branch. So when you try to predict the pattern for this first branch, you look at the LHR for that branch. So you try to predict here, you look at this guy, is 0.211, so is this is strongly not taken, so it predict not taken. Now you try to go, well, now because you have each individual branch, so you can just do 1 by 1, right? Because this is incorrect prediction, you change this to 1, 0. This is going to become 1, 0 as well. The next prediction here is not taken because it's 1, 0. You then update this entry. You update this to 0, 0. The next prediction is again not taken because you add 0, 0. Local counter is going to be updated because you're wrong. Not taken again because you're wrong. And then where am I? So this is going to be updated to 0, 1. Now you predict taken, right? And this is going to become 1, 0, 0 again because it's taken, the last 2 pattern, right? And now this is going to predict taken. So that's the first branch. For the second branch, you will end up with a prediction of not taken because you're at the, again, you first start with this table, followed by this table. This is going to become 1, 0. It's going to become 1, 0. So that's the first 2 branch. The next branch is going to be 0, 0 because LHR is going to become 0, 0. The last outcome you saw from that branch 2, right? Then you will predict not taken over here, then not taken here. This is going to become 1, 0, and because then the next one is going to be not taken and you correct, so it's going to become back to 1, 1. The pattern you see is taken, not taken. LHR is going to become taken, not taken, right? So it's you go to 0, 1, you predict not taken here. And you do the same thing for branch 3. Branch 3, you will see that the first 2 is going to be not taken, right? You start from, oops, let's assume this is LHR 2. My bad, this is LHR 3. Now you start from here, then you go to here. You always predict not taken because the local counter is 1, 1, right? Then the third branch, again, because these 2 you're wrong, you're going to correct this to 1, 0. This is going to change this to 1, 0. This would be predict not taken again because your last 2 pattern is 0, 0. You're here. Now you are not taking, so your LHR from 0, 0 is going to be 0, 1. You look at 0, 1, you're here, you predict not taken here. Now you transition to, again, not taken, not taken. So that's 1, 1. If you add 1, 1, you add this entry, you predict not taken. And that's it. Basically, the idea is the way you work through this is almost like a GHR that you saw earlier, but now the GHR changed to each branch LHR, and you work through each branch LHR individually. Okay, you have worksheet 2 to try for the 2 branches. I think this one only has 2 branches, so you don't need 3 of them, I think. That's the idea about 2-level prediction. All right, and after around 1990s, the branch predictor research work that goes to branch kind of evolved further. So there are more advanced techniques, such as a tournament predictor. This is implemented in the Alpha 21 to 64 in 1999. The idea is, hey, let's use both of them, right? Because the local and global predictor, I mean, they have two things, and I can use either one of those, right? And the reason why we call this a tournament predictor is it picked the better of the two. It picked the better of the two strategy. And then things get more complicated, such as the perceptron branch predictor in 2001. The paper is dynamic branch prediction with perceptron. This is kind of like the first, I think, if I recall correctly, I think this is the first paper that tries to utilize things like perceptron and machine learning into branch. So it learned direction and correlation between each individual branches, then you assign a weight. The reason perceptron works for the branch predictor is simple enough. Once you have the weight, it is simple and fast enough to come up with the prediction. And we use basically this work use supervised learning in branch predictor. I have heard that it's been implemented in several mobile phone, CPU in a mobile phone, actually. And the work I mentioned for many of these work are kind of like the go-to work when you look at branch predictor. There are more follow-up work in branch predictor and how to like utilize things like machine learning, how to simplify the model, how to make it fast enough, how to make a prediction for your branch. Can you use compiler to further help with branch, right? So if you're curious, feel free to let me know. That's it for today's lecture. I want to keep the last few minutes for Q&A as well as a quick reminder about lab 1 that thing exists. I know it's a group lab, so feel free to basically work together. It's not hard. I believe that you can finish everything in a week, but you have more than a week for the lab. Feel free to use Discord. Feel free to do that to tag me if you have any questions so that it pings my phone. All right. That's it for the lecture today. I'll finish the recording. Again, don't forget to finish your lab and work on your lab or ask any questions if it's related to your lab. All right.